Good afternoon, everyone. My name is Terry McVenas, the President and CEO of RTCA. Greetings from our nation's capital, and welcome to all of you to what is now our 10th in a series of webinars, Aviation Technology Connect. We're pleased to have created this series via this platform to hear from a variety of aviation industry leaders on a broad spectrum of topics that will educate you, further inspire you in your profession, and perhaps even evolve your thinking as to where the industry is today and where it is going in the future. The webinar series has attracted a wide international audience of upwards of 400 people tuning in each month, not only from here in the United States, but from around the world, Canada, countries across Europe, the Middle East, Africa, South America, Australia, and New Zealand. And today, as we looked at the list, it's very indicative of that international audience that we have with us today. We have heard from leaders at the FAA, the NTSB, and others from our aviation industry. And we believe that today's webinar is going to be equally exciting and informative. These previous webinars have all been recorded, as this one will be. So if you want to go back and listen to any of our previous webinars, you can find those recordings on the RTCA YouTube channel. We've been holding these webinars on the third Wednesday of each month, and like today, each of these webinars focuses on a particular topic where you will gain insights from industry leaders that I'm confident will be inspirational, strategic, perhaps even thought-provoking, with the primary goal of them giving you, the audience, the gift of their knowledge. And as in previous months, after closing out our panel discussion today on human factors, we'll hear a short tech talk from one of aviation's industry leaders. Now, I know many of you watching today are familiar with us here at RTCA, but I do know we have some first-time visitors. So I want to take just a couple of minutes to familiarize you with who we are. RTCA is an aviation-centered standards development organization whose mission is to inspire the creation and the implementation of integrated performance standards that meet the changing global aviation environment and further ensure the safety, the security, and the overall health of the aviation ecosystem. Now, in addition to developing standards, we also provide training to government and industry personnel on the application of those standards and developing the basis for certification and testing. And on the screen, you can see two of our upcoming training events. At the end of June, we have a course on our document DO-178C and supplements. And in July, we're really happy to be rolling out a new course on a safety management systems overview, which we've teamed with the MITRE company to design it primarily for new entrants to the aviation community. And you can sign up for any of those courses via our website at www.rtca.org. And if you're interested or have any questions about our training, our standards development work, or interested in becoming a part of the RTCA family of members so that you too can have a voice in developing standards, you can contact us directly through our website or via telephone. Now, our ability to bring you these webinars would not be possible without the generous sponsorships from our industry partners. Today, I'm especially thankful to Collins Aerospace and the National Air Traffic Controllers Association, which are our gold corporate sponsors for the entire year, and to Aircraft Owners and Pilots Associations as a corporate sponsor this year, and to Garmin as a webinar sponsor for today's event. Now, we do have some handouts that are going to be available to you from our sponsors, along with all the speaker biographies today, and you can access those handouts. To do so, just download them by clicking on the Documents Handout button that's located here on the GoToWebinar platform. So let's get started. Now, it's no secret that the design of flight decks has changed dramatically over the years. For those of us old enough to have flown 727s or DC-9s, we certainly can attest to the different look and the feel of the flight deck in today's modern Airbuses and Boeings. And that includes business and general aviation aircraft as well. But the one thing that hasn't changed all that much is the human, that is the operator of the airplane. Now, pilots from my generation had to learn to adopt from the old steam gauge cockpit displays to the new design features of modern glass technology. But it's also likely that today's new pilots coming into the industry will also have to adopt over the span of their careers to the yet to be determined advances in airplanes, the avionics, and the various new technologies that will make up future aircraft. Designing that right interface between the pilot and the flight deck has long been the role of a specialized field of experts who have multidisciplinary knowledge base and understood the unique contributions that human factors engineering brings to the design process, including the research, the regulatory requirements, flight deck design, evaluation, and the certification. So as the aviation industry continues to evolve, changes in that flight deck design and the regulatory certification process are going to be changing as well. And even today, human factors engineering goes beyond solely that pilot-machine interface. It's a much more detailed discipline that involves such things as the physical, the psychological, the physiological, and the cognitive performance capabilities of flight crews. And an understanding of the limitations of flight crew performance, how it's impacted by systemic variables in the flight deck environment, crew workload, and human error. So today I'm really pleased to be joined by 7 of the world's leading experts in human factors engineering and flight deck design to discuss how we can work together to enhance that integration of human factors from concept of design through the product certification, as well as address some of the current challenges and opportunities that face us today. So first, I'd like to welcome Dr. Kathy Abbott. Kathy is a longtime associate and friend of mine. Dr. Abbott serves as the Chief Scientific and Technical Advisor for Flight Deck Human Factors at the Federal Aviation Administration, addressing human performance and human error, equipment design, and flight crew training operations and procedures. Second up, Mr. Christopher DeSalvo from Collins Aerospace, where he serves as a staff human factors engineer. His current focus is on the Part 25 human factors certification process and execution that supports both OEM aircraft and primary applicant programs. Professor Colin Drury is a State University of New York distinguished professor emeritus of engineering at the University of Buffalo, and he currently is the president of Applied Ergonomics Group. He's a private pilot and has written over 200 publications on human factors topics in aviation maintenance, inspection systems, security inspection, and safety. Next, Dr. Barbara Holder is a technology fellow at Honeywell Aerospace, where she leads Honeywell's crew interface technology strategy and chairs their crew interface technology council. Barbara conducts research on real-world cognition in flight operations to improve safety and system performance. She's developed improved flight deck procedures and checklists, new flight deck technologies, and advancements in flight crew training. And also from Honeywell, Dr. Ratan Khatwa is the Senior Chief Engineer at Honeywell Aerospace and provides human factors leadership and vision across Honeywell's flight deck systems product portfolio. He has made significant contributions to the development of advanced flight deck systems, including enhanced ground proximity warning systems, weather radar, runway overrun awareness and alerting system, navigation displays, airport moving maps, and synthetic vision systems. And last but not least, Dr. Florence Reuzeau is the executive expert in human factors at Airbus. Unfortunately, we're having a few technical difficulties this afternoon with getting Florence video working, but she's on the line. She's in charge of leading the human factors expertise stream of defining the human factors strategy for research and program development. Her defined strategies are incorporated across 3 divisions of Airbus: Airbus Commercial, Helicopters, and Defense and Space. She was a key contributor to the definition of the EASA's human factors regulation as it applies to cockpit design. So to all of my panelists, welcome. It's an honor to have you all here with us today at RTCA. We have a lot of material to cover. So what I'd like to do is to break our discussion up into 4 parts. And we'll start first with just the definition of human factors engineering. And then in part 2, we'll delve into more of the regulatory foundation and basis for human factors. And then part 3, we'll hear, at least from a human factors perspective, what it means to be an airplane manufacturer or a supplier. And then we'll close out with part 4 and just have an open discussion on the next generation of human factors in flight deck design and certification. So to get things started, I'm going to turn things over to Dr. Drury to set the stage with his perspectives on the definition of human factors and its importance in design, certification, and operations. Dr. Drury?
Thank you very much, Terry. I'm going to just be talking about the importance of human factors. Next slide, please. So we need to define it first. You can read this as fast as I can. Human factors is really concerned with the interactions between humans and other system elements to do two things: optimize human well-being and overall system performance, both of those being very important in this context, obviously. I tend to prefer the more modern term human systems integration because human factors get misused quite a bit in the lay public, and HSI does tell exactly what we do. So where did we start? We started in aviation in World War II with military cockpit design. And that's where we've been ever since, and that's where we are today. We're in a lot of other things as well. Next slide, please. But if you look at what's happened over the years, as Terry was saying, we've moved from steam gauges, which lasted a long while. I've just put in from World War II up to 69 from DC-3. It's actually a C-47 commercial, military, to the Concorde 1969. And most of those instruments and controls would have been quite recognizable from somebody coming from a DC-3 to somebody going to a Concorde. Obviously, the magnitude of the interface has increased considerably. Next slide, please. But we then moved from individual dials to something that was more integrated. So instead of the operator, the pilot in this case, trying to make sense of single individual parameters, they were given a more integrated look at what goes on. And this has lasted quite a while. I've put first flight 1987 to first flight 2009 of two well-known planes. But again, the instrumentation and controls would have been quite recognizable from one to the other, and also to some extent from people used to steam gauges. Slide, please. Okay, and there we go to the future. It is still quite recognizable. Flight deck technology has evolved, obviously. Human factors understanding has had to evolve to meet the new challenges. The issue is always, does the pilot understand the complexity behind the display and what it's going to do? So next slide, please. Just a couple of things on how human factors works. There are really two aspects: designing the system to fit the user, designing the user to fit the system. Both are important, you need both. Translated into the terms we normally use, you need good physical and cognitive flight deck design, and you need good training. Both are important, but it's important also to realize that even very good training cannot make up for problems with physical and cognitive flight deck design. Get the hardware and software right, then training becomes much easier. Next slide, please. Okay, so what do we do in human factors? We look at where errors arise, because this is one of the chief problems, is errors. There is also the other side to this, where the human in the system is not somebody who makes errors, but somebody who saves things and somebody who is hero. But we'll just stick to the errors for now. Errors occur when the demands of the task are greater than the human capabilities brought to bear on this. That's a general thing, not just pilots. So we need to understand what are the human capabilities and task demands on each of the different subsystems of the human. And Terry talked about these. The physical, fairly obvious, we've been able to do this for a long while. The sensory, we know vision and hearing, we know font size and so on. Cognitive and social are the two things which are changing and particularly important in any cockpit design. The cognitive one is, how do people make sense of what's going on? How do they gain and maintain situational awareness? How do they do correct decision making, particularly under stress? And then the social, this is what's usually known as human factors in certain parts of aviation, the hierarchy on the flight deck, the shared understanding of what's happening. So next slide, please. Now we move on to where human factors fits into the process. So obviously design, certification, and operations are all important, vital. You cannot do without them. And you need all of them to operate a safe aircraft. So I'll pass it on now to part 2. Thank you.
Thanks, Colin. It's a great start. I'd now like to bring Dr. Abbott in. Kathy, how are you?
Doing well. Thank you very much, Terry.
Well, as I mentioned in my opening, that human factors is more than just the pilot-machine interface. I know that's something you and I have talked about many times over the years. So I'm going to give you the floor now to talk some more about this, as well as some of the maybe some of the other concepts that make up that regulatory foundation behind human factors.
Great. Thank you very much. And I will emphasize that this is a regulatory perspective about design and certification. It's not actually all of the regulatory side of things, but we are focusing on that. Next slide, please. So as I said, it's aircraft certification focused. And if you go to the next slide, please. One of the things that I wanted to share with you was that I'm using the term human factors with a simpler definition, and I'm using it here to mean anything that affects human performance. Another point that I think is very important to make about human factors in aircraft certification is that many of the regulations involve human factors considerations, or they have human factors consequences of the designs that result from the regulations. Some examples that I'd like to use. The first one is one of the major human factors related regulations that many people think about these days, and it's relatively new, 25.1302, which covers installed systems and equipment for use by the flight crew. And that gets into the design related pilot error, among other things. 25.1309 on equipment systems and installation covers system safety assessments, flight crew alerting, flight guidance system, which covers the auto flight system, autopilots, auto throttle, auto thrust, and flight director, and 25.1523, which covers minimum flight crew. That's just a sampling. There's actually many more regulations that have human factors aspects to them, but I wanted to share those examples. Next slide, please. I'd like to share some key points. One of them is that the regulations should not be considered in isolation. Part 25 is a package of regulations, and there's many pieces to it, and they are designed to be complementary and to work together. So that's one important piece to keep in mind. A second point is that the flight crew interface is critical. It's very important, but it's not everything. The system behavior from the perspective of the pilot is also very, very important and is covered in a couple of the regulations. Next slide, please. Going to share two of those with you. Under 25.1302, installed systems and equipment for use by the flight crew, paragraph C talks about operationally relevant behavior of the installed equipment. So it's not just the interface between the pilot and the system, it's the behavior of the system. And that behavior must be predictable and unambiguous and must be designed to enable the flight crew to intervene in a manner that's appropriate. Under the regulation for flight guidance system, 25.1329, paragraph I also talks about behavior, specifically that the flight guidance system functions, controls, indications, and alert must be designed to minimize flight crew errors and confusion concerning behavior and operation of the flight guidance system. So I just share those to emphasize the importance of looking at the behavior as well as the interface. You can have a good interface to a system that's behavior is confusing, or you could have a bad interface to a system that's well designed for its functioning behavior, and either one of those can cause issues. So that's why it's important for us to look at both. Next slide, please. A few other points. Appropriate human factors topics need to be considered, and that means all of the human factors aspects of the regulations themselves. And also human factors in design and certification needs to be done early and often. And with that, thank you very much.
Thanks, Kathy. Great start. I'd like to just now move on to part 3 of our journey by bringing Florence Reuzeau on. Can you hear me, Florence?
Yes, perfectly. And you, can you hear me?
Yes, very well, thank you. Thanks for joining us, because I'd like to now first hear some perspectives from the airplane manufacturer. During my career at Boeing, I learned early on that anything that goes on an airplane has to earn its way onto the flight deck by showing value. That was a lesson that many a program chief project engineer reminded me of regularly. And so I'm sure it's the same at Airbus. So I'd like to turn things over to you to talk a little bit about how human factors integration brings value to your business.
So thank you, Terry. So it's a pleasure to present how Airbus is integrating human factors in flight deck design and certification, providing value to business. Next slide. So first, what is a domain of interest regarding human factors for Airbus as an OEM? We have to consider human performance with 4 key elements. First one is the way the job is defined and the task and the procedure in order really to define the job of the pilots and the crew. Second element is the working means, mainly, of course, the flight deck design, the layout, and also how the systems are defined in the cockpit. Third part is the organizations, because we know, for example, that shift pattern organization is very important for long-range operation to manage the fatigue of the pilots. And the last part is individual capacities and limitations, and of course the competence of the flight crew. We have to consider safety first, but designing and certifying a cockpit, we are also considering the impact on operational efficiency for the airlines and the end user experience, because it's a really key if pilots can enjoy the life on board and flying the aircraft. We know that there is a large impact on motivation and engagement, and the passenger experience, that is the final objective of all of us to offer this flying experience to the passenger. Next slide. So how we can do to integrate human factors in design and certification in an OEM context. 4 pillars. The first one is governance of human factors, of course. So we have established a governance at Airbus commercial level and also at group level in order to really position human factors at the appropriate level in terms of decision making. Second pillar is process, method, and tools, very basic, but very key, because we have embedded a human factor design process officially in the other Airbus processes. Our process is based on ISO 9241, the user-centered design. So very, very easy to develop this process. What was important, it is to adapt this process to the Airbus context. The third pillar is people. It is really important that we have good human factor specialists, good competence to do the activities. When we say good, it is Master 2 or PhD in human factors in various disciplines, physiology, psychology, sociology, linguistics. And at the same time, we have developed a human factor expert stream from experts, senior experts, and executive experts in order to be sure that we master the competence. The last pillar, and not the least, is collaboration with key stakeholders in aviation industry, authorities, airlines, laboratory, air traffic management, and the other OEM and suppliers, in order to be sure that we understand collectively what are really the human factor issues based on these human behaviors, digging with new technologies. Next slide. Just to take a concrete example, we have applied this human factor process and certification, human factor design and certification process on the definition and the development of the keyboard cursor control unit, that is the interaction mean for the A380 and A350. Next slide. So of course, the objective of this interaction mean is to facilitate, to simplify the interaction between the crew and the cockpit, dealing with the information and main information in the cockpit. Next slide. So to figure out how we have defined, developed, and certified this cursor control unit, we have implemented an iterative process with several loops of design, implementation, validation, and certification. And during these different loops, we worked on physical shape of this interaction mean to fit to the pilot biomechanics, avoiding, for example, musculoskeletal disorder. We worked on the location of this device, and also we work a lot on the cursor movement law in order to allow a quick and natural access to information. Finally, of course, the objective is to allow the pilot to focus on the main task without having to think to the interaction. So next slide. What we have to do in the future, the key challenges, we have to consider and we have to work together in order to understand what can be the key impact on human behavior when new technologies, decision-making supported by artificial intelligence, image processing, these new technologies one day can enter into the cockpit, and we have to work together to really understand the impact on human behavior. We have not to forget also that we need to understand how the pilot of tomorrow, the next generation, will behave, and also what can be the kind of aspirations they will develop. But today, the key challenges are really how to be perhaps a little bit more efficient in answering the certification regulation, because today, as Cassie mentioned, human factors regulation can be found in 1302, in 1322, 1523, and the 1309, the regulation linked to the safety assessment. And there is open discussions, but we have to work collectively in order how to enhance the way of working, but being very reasonable by focusing on added value for safety. So this is just for the Q&A, and we will come back, of course, on this kind of question in the Q&A. Thank you very much.
We will move on to hear from the supplier side of the house. So I'd like to bring Christopher onto the webinar stage. Welcome, Christopher. So from the supplier's perspective, talk to us about the role that HF has in your business, both in working with the customers, but also with the regulator.
Certainly. Yes, again, Chris DeSalvo with Collins Aerospace, and I'd like to stay on this slide for just a moment. I think I will be able to answer that question as we go over the next few slides, but from a supplier standpoint, human factors has a lot of roles to fill. We've got a lot of stakeholders internally and externally that we need to have sort of a two-pronged approach. One is to help educate our coworkers in terms of what human factors can provide in terms of its value, and then also to do the role of human factors, collecting data, and helping to create together with our systems, safety and software domains, the products that you see. So that brings me to this picture here. This is a Textron Beech King Air with Collins Avionics on it. This represents a touch display. So when you look at it, I'm sure, as most people on this webinar are familiar with avionics and aviation, that you'll see a lot of the standard display of attitude control, airspeed, heading, that type of thing. And that is certainly true. When I look at it, I also see years and years of heritage of designs that have been built, solid foundations that have been built upon with increased capability. Touch is just one of those examples. And that's a very similar story for a lot of the other suppliers in the industry as well. So again, the point here is that a lot of what seems to be automatic in terms of what we produce in avionics requires a lot of work, a lot of design choices, and a lot of managing the different expectations from customers, users, and certification agencies. Next slide, please. So human factors at Collins has been an integral part of what we do for over 30 years, and that's no different from most of the major suppliers. And the reason I say that is no matter where you are in your awareness of human factors in the industry and even beyond aviation, you can rest assured it's been there for a while. It may manifest in different ways. So as I mentioned before, we in human factors work closely with systems engineers, certification engineers, software engineers, the users. So we have a very unique and interesting perspective across sort of the whole of what we do to produce avionics that goes on aircraft. So in terms of certification though, there's two main categories. One, Collins and other suppliers have the ability to be the primary applicant. So Collins Aerospace would receive a supplemental type certificate for, let's say, an upgrade of an avionics system on an existing aircraft. So as you can imagine, that's a unique role where we would have direct interaction with the regulatory agency like the FAA. And it allows us to have a little bit more control over what we can bring to the market. But obviously we have to make sure we understand that market to be able to bring solutions that are really going to be well received. And then obviously we are supporting OEM manufacturers, like I mentioned, Textron, Beech, and there's others obviously, in their seeking of a type certificate. So that becomes a little bit more of a challenge with a lot of opportunity as well, that we can interact with both the customer and indirectly with the regulatory agency. And then we have the benefit of bringing our past experience certifying or helping to certify avionics on other programs as well. So really early definition of supplier generated human factors needs, what sort of reports, documentations, is really going to be required to integrate well with the OEM. So human factors done late in a program costs everybody more money than we'd like. Human factors done early yields a lot of dividends. Next slide, please. Okay, so as I mentioned, human factors is a well-known discipline in industry. And again, I resonate with Colin's mention of human systems interaction. I know somebody has at least a rudimentary knowledge of human factors when they don't accidentally call it human resources, so that's good. But I do believe and feel that human-centered interaction is a very appropriate way of talking about it. But we've seen that there's emerging greater public and industry awareness of human factors, which is a good thing. I think one of the unintended consequences is if somebody is not that familiar, they may think that it's new. And we're certainly evolving. Kathy mentioned 25.1302. It is relatively new, as she said, but it has been around for, I think, almost 10 years now. And I think the reason it's viewed as new by certain people that only have a peripheral awareness of human factors is because the development cycle time of avionics and aircraft can be quite long. So one of your coworkers today might be very familiar with what a 1302 program looks like, whereas the next might be only familiar with some of the older ways of applying human factors to a program. So like I mentioned before, I think I view human factors as two jobs at once. One is to help educate your fellow coworkers, that are in other disciplines about the value of human factors and how it's not a charge or a tax on getting a program developed and certified, but really can have dividends. One example is creating a system that it makes it incrementally more easier for pilots to use, is going to lead to increased infinity down the road. And then another aspect of education is really serving to increase the overall corporate awareness of human factors and sort of an ethos and appreciation for, and that has multiple benefits of making sure we have flow of talent and making sure that everybody's at least aware of the value that can be brought. And then obviously there's doing the human factors work. So that has to be something that meets the needs of the program, next week, next month, prior to that first certification or that first flight. But it also requires awareness and focus on the fact that certification is not the only goal. Obviously, it's a critical goal. But to be able to work towards progressing the industry and progressing the solutions that we can provide has opportunities to make flying a more enjoyable and an easier situation for pilots to handle. Thanks.
Well, thanks, Christopher. I appreciate that. So let's turn things over to Honeywell now. Dr. Holder, Dr. Khatwa, same to you. I'd like to hear some of your perspectives as a supplier. And Ratan, why don't you go ahead and go first and tell us a little bit about human factors and the design process at Honeywell, and then Barbara, perhaps you could share some of the challenges that you face as a researcher there.
Terry, good morning, good afternoon, everybody, good evening, depending on where you are in the world. It's indeed a pleasure to be here today certainly with my co-presenters. And what I'll do in the next 5 minutes, I'll try to present a day in the life of an avionics supplier, and some of what I'm going to present is going to jive with what others have already presented, but it's a lot to push into the next 5 minutes, but I'll try to do justice to the topic. Next chart, please. So the key takeaway, and I'll walk you through this chart, but the key takeaway here is that an avionics supplier design space is enormously broad, it's complex, and it's challenging. And the reasons, and there are some reasons given on this chart here, and I'll just sort of walk you through some of these things. I'll make references to a couple of aircraft, and it's not an advertisement. I think it just gives you really context for some of what's on this chart. And, as Chris has already talked about, most of us in the avionics supplier world, we're really engaged in developing multiple flight decks simultaneously. And really what that means is, dealing with different aircraft manufacturers and their flight deck philosophies. And of course, naturally, all those OEMs, the manufacturers, they naturally want product differentiation, yet we're providing, a lot of common systems across those individual flight decks. We're dealing with an environment where we're, having to deal with a retrofit. So, for example, the recent A300-600 retrofit that we did for UPS, forward fit applications. You just seen an announcement recently, the Falcon 10X. So it gives you an example of just that broad space that we're involved in, single and dual pilot operations, right? And so, you know, think something like PC-12 or PC-24 from Pilatus here, fixed wing and rotorcraft. So if you think about the AW139, for example, clearly a Part 29 application. And so really what we're doing is we've got a broad space here from Part 23, from Part 25, and Part 29 now. And some of this has already been mentioned in the past. You know, we could be doing a TSO with a concurrent STC. For example, we could be doing a RAS, a runway awareness and advisory system retrofit with an airline as us as the applicant, for example, on a Boeing 777, right? And then lastly, you know, we really are working with supporting the OEMs with either a brand new type certificate or an amended type certificate, and that could of course occur on a major block upgrade to the avionics suite. And as a result of that, you know, we are dealing with multiple regulatory authorities around the world, just because our customer base clearly is global. So this is really the key takeaway, right? This is broad, it's complex, and it's a very, very, very challenging environment that we work in. That's our design space. I'll take the next chart, please. I'm not going to go into the entire human factors process at Honeywell, but just to sort of give you a key idea here. Key takeaway here is that human factors, design and certification, it's a classical human-centered design process that we use, which means it's iterative in nature, which means data drives the design decisions as opposed to just people's opinions, and the end user, flight crews, are really partners in design. And that first block at the top there, crew acceptance, that's what that's about, right? Is that we really have flight crew that are really partners in design. The second piece here, as Colin's talked about, is human performance. That really means meeting the intended function for that integrated flight deck. And the kinds of things that Colin's already talked about. You know, we've got obviously a focus on cognition aspects such as crew errors, such as decision making, such as reaction time, time on task. Obviously, there's a lot more to it than that. You know, if we're looking at design of a cursor control device, you've got physical aspects such as palm pressure, strain basically on the wrist. If you've got if you're looking at basically a forward a touchscreen device, you'd be concerned with basically shoulder fatigue and etc. So those are the sorts of things that really fall in that bucket, which isn't just what they say, which is crew acceptance, but how well the system performs per the intended function, and we have to of course measure that. HMI design, which is at the bottom there, clearly visual design, interaction design, industrial design are key components of this, and some of this has already been talked about with some of my colleagues here already. But the key here is that we need to make sure that we are compliant with a flight deck philosophy. We need to make sure that with the appropriate use of font, the appropriate use of color, you know, making sure that we've got dead space or white space, if you will, in those places that need it, the appropriate design of symbology. All of that really falls in this particular area here. Now, to the right of this diagram, you're seeing the impact on crew training, SOPs, and checklists. You can't design a flight deck in isolation. I'll use an EASA term here, TASE, training area of special emphasis. It's an area that we focus on throughout the design. We're trying to uncover, of course, impacts to either the SOPs and or crew training, and of course validating any assumptions that we may have at the beginning of the programs. That's really the key piece there, and we work obviously with our OEMs with that. The bottom left, what you'll see is in the brown there, HF cert compliance. It's not to indicate that this is last, because it isn't, and it is not a check at the end of the program. It's very, very clearly needs to be baked in throughout the program from the beginning. I'll give you a couple of examples, and I use some words very deliberately. Human performance, I talked about meeting the intended functions. That's 25.13.01. Kathy talked about the appropriate use of color. You know, that's 13.22, right? We look at 13.02 and we look at system functional behavior. What's it doing and why? The fact here is that you cannot wait till the end of the program and do this big compliance check. That's got to be baked in throughout the design process. And really the key takeaway there is that the design of that UI, whether it's a physical control or whether it's a display, all of that integrated flight deck has to really meet the spirit of those regulations, even if we as a supplier are not the applicant, for example, in a TC. So that's really the key process here. You've got these building blocks, there's a lot more to it, but this is really the areas that we focus on as we're developing these standalone offerings, as well as an integrated flight deck. Next chart, please. This is my last chart, and we've been asked to really talk about where are their successes and where are their challenges. And I'll start with the left-hand side here. There is no question that the introduction of 251302 from both the EASA and the FAA has elevated the presence and the importance of human factors, certainly at our organization. And as a direct result of that, and Florence talked about this, our systems engineering process has been impacted. It really means that we've got a systems engineering process that encompasses human factors as a core design. I've already talked about the fact that we follow a classical human-centered design, and what that really means is that as we develop our requirements, as we validate those requirements, of course, the end user partners, the end users, the flight crew are partners in design. It's data that drives that design, right? And the validation, the design and the validation is necessarily scenario-based. This last point on the left-hand side has already been talked about. I just think it's been a fantastic experience with all of the certification authorities over the years, where we've got, even when we don't have a program open, there is earlier and often certification authority engagement, and that really benefits everybody in the long term, because identifying and resolving those issues early in the program is clearly paramount here. Right-hand side, the challenges, I just want to make sure everybody understands the context here. I'm not pointing fingers, I'm just reporting the news and the weather, if you will. One of the things that we're finding is that to find human factors expertise for integrated flight deck development, in other words, for product development, has been a challenge for us. It's a scarce commodity, and I think there's probably some food for thought here in terms of how we partner with academic institutions. The use of red and amber, I think there's many people on the webinar are probably familiar with this, specifically for non-alerting situations. It caused some instabilities in some of our certification programs or our customers. Again, no blame intended here. It's an area that I think we could work collectively with the industry and with certification authorities to move forward. The third point here, Chris has talked about a little bit about this, is that we've got some of our OEMs that feel that the suppliers are doing a lot of human factors work up front. How can they benefit from that as part of their certification program? Now, there isn't really a formal path to do that, but I think this is an area where collectively the industry, together with the government organizations and the cert authorities rather, can really make some impact. And I'll just move to the last point here, which is really human factors standards, lagging technology introduction. And unfortunately, again, it's just reporting the news where we're finding that we've introduced something or our competitors introduced something, and 2 years later we get an industry standard that is relevant to that particular technology. So, ladies and gentlemen, I appreciate the time. I'll hand over to Barbara now. Thank you very much.
Well, good afternoon, everyone. It's my pleasure to share with you some of the research challenges that we face in human factors. We've talked about design and certification, but it's an exciting time for human factors flight deck research. Next slide, please. For example, there are multiple drivers for automation, and they include new entrants like you see here. There's advanced air mobility vehicles, there's supersonic business jets, and all other kinds of new entrants that are being developed that are highly automated, simplified flight decks, and even some are planning to fly autonomously. Another driver is the global interest in reducing crew and single pilot operations to meet the demands of a global pilot shortage. There's also a resurgence in AI and machine learning technologies, and some very recent high-profile accidents And all of these are some of the drivers that are pushing the industry for more automation. But in safety critical systems like aviation, there's this natural tension between safety and innovation. We want to innovate, but we can't compromise safety. And so we have to be careful and thoughtful about what we change in the system and how. We have an opportunity to design really good automated systems based on decades of flight deck human factors research. But we need additional knowledge and understanding to help us meet these new challenges. Next slide. There are a lot of research questions that are really interesting, and I've highlighted 3 here, but this is by no means all of them. And a lot of these are speaking to this push for more automation. One area that we really need some work to be done in is to document the cognitive work of pilots. Before we can contemplate automating pilot activity, we first need to understand how pilots think when they fly and how they contribute to the safety of the system. Automating control tasks is simple, but automating pilot cognition and expertise is not. Because flying is fundamentally cognitive, we need to formally document and describe the cognitive work of the humans in the system if we intend to automate it. Another area that we need to identify, research and answer questions is in the appropriate pilot automation teaming concepts. There's a lot of interesting questions here around understanding how to design collaborative systems that capitalize on the strengths of the human and on the automation. How do we create effective pilot automation teams? How should they interact? And how do we design systems that maintain appropriate levels of workload for the pilot? How are the roles of the human and the automation defined? Another really interesting area is understanding how to convey information to pilots across multiple modalities. Current flight decks are visually demanding, and we need to explore the use of other modalities, such as oral and tactile, to convey information to pilots in novel ways that engage all of the sensory channels and do so to reduce workload and increase understanding. We're starting some of this now, but there's a lot more work to be done. We should also be improving the design of the existing systems. Not only are our flight decks overly reliant on the visual channel, but we can improve what we display visually today. Next slide. We have an opportunity for real innovation, and the human factors discipline is well equipped to address these important research areas, but we need to do it. We have the frameworks, we have the tools, and we have decades of insight to draw upon when considering the design of these new technologies and systems. We should continue adding to the body of knowledge with new research that will help us design innovative flight deck interfaces and automated systems safely. Thank you.
Thanks, Barbara. I'll invite everybody else now to come on the virtual stage for just a little bit of an open discussion and answer a few questions that I have and a few questions that have come in from the audience. I think I wanted to kind of talk about the future, but I also want to make sure we have a good understanding. There was one question, I think it's best for Kathy, about what kind of guidance is available for folks for system component manufacturers in terms of considering the compliance requirements for the certification of the component. I know there's advisory circulars. Is there more?
There's advisory circulars, there's industry standards that are out there. Certainly RTCA is one of them, SAE is another, ASTM is another organization. We think that the industry standards are very important, and that's a key piece that we point to. We do have guidance material. We also support research Barbara mentioned research. That's an important component of what the FAA supports, and that research is used to inform our guidance, our policies, and other documents. Depending on which specific topic area you're interested in, we do have a number of them that that people could use to support their information that they're looking for and any kind of guidance.
Great.
Might be an interesting question to ask some of the people from industry what their favorite is.
Yeah, I mean, I think that's a good lead into, you know, obviously RTCA is a standards organization, and Kathy, you mentioned a little bit of the role of those standards. From the suppliers, I mean, what do you see as the role of those standards? Is there more that can be done with those standards, modernize them, or whatever the case may be?
I can take a shot if you want, Terry. So I mean, I agree with Kathy. You know, there's a lot of good material out there already. You know, in terms of, you know, if you just read the AC for AC 25 1302 or the AMC from EASA, there's a huge section on certification planning. You know, that's section 4. I'm sorry to know this stuff in my head, but even just individual things like that are important. I mean, when we start getting across the different sort of flight deck functions, you know, whether it's synthetic vision, whether it's TORs, I mean, there are a number of TSOs, there's a number of RTCA standards, for example, for map functions, you know, 257B, I think it is now, you know, there's DO317B for, I think it's at Bravo now for ADSB type things. So there's a lot already out there. And then you've got, you know, a host of things from, as Kathy's already mentioned, from SAE, you know, I mean, across the flight deck. I think, you know, one of the key things here, though, Terry, is we've got a lot already, and I think collectively we know what those things are. I know the FAA, Kathy, you'll have to remind me which AC you had. I think it was an informational AC that was released, I think, in the last 2 years, which catalogs a lot of that information. So I think for those who are not familiar with it, it'd be a great, it'd probably be a good thing to mention, Kathy, for them, what the number of that informational AC is. And then I think, Terry, for somebody like RTCA and EuroK, you know, collectively, I think it's worth, you know, we're not going to solve it here today, but, you know, one of my comments was I still feel that there are things that industry's doing where we're finding standards are coming in later. Now, sometimes better late than never also applies, but I feel that that's probably an area of, you know, discussion. Barbara's already talked a little bit about it, you know, in terms of multimodal, you know, inputs to a flight deck. I'll just pause there and give the others time, but just my initial response, Terry.
Kathy, did you have?
Yes, 00-74.
Great, thank you. So I want to talk just a little bit about, you know, where do we go next as an industry? I mean, we've had, you know, some high-profile accidents in recent years. We've had other accidents that maybe have occurred a long time ago. How do they help drive, you know, our direction with the role of human factors engineering on the future? Just hoping that anyone who'd like to speak to it. So.
I can take a start, Terry. So one of the ones I'm interested to hear more about is the notion in industry of even more integration with human factors and the safety organizations. So 25.1302 being human factors, one aspect of human factors, and 25.1309 having to do with safety. Now, this is nothing new. They've always served sort of the same end goal. But I do think that there's lots of potential in the industry to focus on the integration of those two disciplines to be able to continue to improve the ease of use, for pilots, increasing and augmenting their situational awareness and helping them maintain that situational awareness during flights and during times of error. And so there's a lot of opportunity in the future to collect data, potentially even collect data in real time. That I think is going to be one to watch.
Any other thoughts?
Do you want me to take a shot?
Sure.
Kathy, I thought you were about to speak. I'll take a quick shot. So I think, Terry, there are probably a number of areas here, given, the direct question. So I think one of the key things, certainly this is a personal perspective, and others may disagree, is competency, and Florence talked a lot about that in her presentation. I think there's an opportunity here to partner with the academic institutions. I'm not saying that we're not getting good people come out, but it's becoming increasingly more difficult, I feel, to find talent that specifically is interested in, again, product development and certification. And again, it's not throwing any stones. I think that's one area in terms of the bigger picture. The second, and I'll just quickly be very quick on the next two areas. I think the second thing is in line with what Chris mentioned. Some of us have been in the industry, for several decades now, and it's not that we've been doing the same thing over and over again, but I think there's a lot of pure research that's been going on in the background that industry may be not aware of in terms of, how do we measure human performance, right? A lot of us are used to, the same old ways of doing those, whether it's a Cooper Harp or a Bedford or using, physiological measures. But I think there's a lot that's gone on there. And so the umbrella that I really want to bring to the table here is, or the bucket, is human factors design and evaluation methods. I think that they've moved forward. And yet I think, the industry is perhaps not aware of everything that's happened there. And then lastly, just in line with that, and I think there'll be several people on the call that may have something to say about this. For most human factors people,
Like he froze up a little. Okay. Hey, we're kind of running out of time.
To be disrespectful. I think the area of doing system safety analysis and functional hazard assessment, we need to really move forward, with thinking in that area and mature it. I think that's really the key point.
We've got time for maybe one more question, as we're just about out of time. And I want to just touch on the role of organizational leadership and culture inside of organization, and how that impacts how companies, or even how the regulator deals with the human factors issues. Do you see any changes going on in that culture, or does there need to be more change?
Well, I can certainly weigh in that we're seeing a much increased interest in the area of human factors, especially in design and certification, but not just that. And if you look at the most recent FAA reauthorization language, the legislation has an awful lot of language in it related to human factors. I think there was a count that it shows up 35 times in that particular legislation. So lots of interest there. Having the management be very supportive is really important, and that makes a huge difference. I was delighted to hear Ratan's comment about the influence of 1302. There is one point that I wanted to raise that I think is an important one, and I don't want to take up a lot of time on it, but just the awareness and understanding of what human factors is about, and the fact that depending on what you're applying it to determines what subset of human factors you need to look at. It's a very broad field. And what you need for design and certification is not necessarily the same thing that you need for, say, flight operations or maintenance or other things. So needs to make sure that we focus it in the areas that are necessary for the application it's being used for.
Well, I hate to cut us off because we are out of time. We've got, this is just a tremendous topic and a lot of different aspects to it. And probably it will form the basis of a follow-on webinar and down the road, so we can do a little bit deeper dive in some of the specifics. But I do want to thank you all for this great discussion. apologize to the audience that we had the trouble with Florence's audio and video, but we're going to use some really good human factors engineering. And for the YouTube version, we're going to go ahead and splice in her presentation into the YouTube version, so the audience can get the whole version of the webinar that way. So thank you all. Again, very great discussion and very informative. I want to take just a moment before we move on to give you a preview of a new training course that we have coming out later this year on the topic of human factors. RTCA has teamed up with some recognized human factors experts from the industry, government, and academia, some of whom were part of this panel, by the way, to collaboratively develop a new training curriculum in human factors. And as you've heard today, the field of human factors engineering consists of multidisciplinary knowledge and practitioners. And consequently, there's been many academic programs in human factors available at the bachelor's level, the master's level, doctorate degree levels. This RTCA course is designed to complement that academic knowledge base and provide a practical, applied perspective tailored to the role of human factors discipline in the design and certification of flight decks. The course is going to be aimed at managers and engineers with little or no background in human factors. It's not intended to train the method of human factors, but rather to provide sufficient knowledge and awareness of those methods to enable engineers and managers to determine where that human factors has to be applied in the design process and the associated human factors role. So we're looking at rolling that course out in October. So I'll ask everyone to stay tuned for some further information. So thank you all. Appreciate you joining us today. Now, I want to take just a moment to thank all of our sponsors again for today's event. Even during these difficult times, these organizations have been gracious enough to make today's webinar happen. And again, my thanks to Colin G Aerospace, NATCA, Garmin, and ALPA as sponsors for today's webinar. Your continued support to the industry and to RTCA is very much appreciated. Well, now I'm pleased to introduce this month's Tech Talk speaker, United Airlines Captain Bob Fox. Captain Bob Fox serves as the Airline Pilots Association's International First Vice President and its National Safety Coordinator. He oversees ALPA's Air Safety Organization, which manages the union's safety, security, pilot assistance, and jump seat programs. Captain Fox serves as the industry co-chair of the FAA's Flight Standards Transparency, Performance, Accountability, and Efficiency Aviation Rule Committee. He's a member of one of the subcommittees of the Next Gen Advisory Committee and is the pilot representative for the U.S. Department of Transportation Safety Oversight and Certification Advisory Committee, which advises the Transportation Secretary on policy matters related to aviation safety. In addition to those responsibilities, Captain Fox is a member of the ICAO Cooperative Oversight for Cross-Border Operations Subgroup. And if that's not enough, Captain Fox also flies the Airbus A320, and he's based here in Washington, D.C. So, Captain Fox, I'll send it over to you.
Hey, thanks for that, Terry. Great introduction. And we can't see each other, but I wanted to welcome all the engineers on board, and I do appreciate the work that you do each and every day. I'm sure I've flown airplanes that you've worked on or systems that you've worked on. And for the pilots listening in, I'm hoping to bring some stick and rudder skills to this discussion. Terry, I would be remiss if I didn't start out and thank the RTCA for all the work it does. Over a year ago, you know that the Airline Pilots Association was looking for standards on cleanliness and sanitation for our cockpits to protect our crews from COVID. And your team went to work bringing in 70 people from around the world, and in 100 days actually developed those standards that are necessary to protect our crews on the flight deck. It's been a real interesting discussion. I understand that the world is always moving forward from a technological perspective and wants to move forward with new innovative designs. I think it's important for me to talk about where we've been and how we've gotten here. And ALPA, as you know, Airline Pilots Association, has been about safety for the last 90 years. And when you look at how we've gotten here, there's been a lot of hard work put into place to make the air transportation system what it is today. And I think that we'll all agree that COVID, the pandemic, has brought back to how precious life is. And we need to recognize each and every day that we have pilots flying on average 200 people in their aircraft to their destination. And those people on board those airplanes are thinking about the vacation they're going to, the wedding that they may be attending, or just going overseas to study abroad. They're not thinking about that their life is in jeopardy, and that's due to the large part of the work that's been done to this date. Primarily, I want to recognize North America for everything it's done. And in the North American region, I can't emphasize the importance of 2 highly trained, highly qualified pilots on the flight deck, supported by a strong safety management team. And let me get into some details on that. Pilot qualifications, what do I mean? That there's a standard there that provides academics in aerodynamics, weather, and navigation. And then there's a standard that says you must be, there is a practical aspect of this. You must get in an aircraft, you must take off, you must land, you must learn how to fly that airplane. You must learn how to deal with an emergency in the air, supervised and signed off by instruction. And then you have to go out and gain experience before you're allowed to go out and fly 200 people from, let's say, Los Angeles to Kennedy Airport in New York. That standard has produced a license that the pilot then takes and can get on that flight deck and fly those people. On the training side of the house, pilots are taught in the academic environment, initially on their aircraft, how the aircraft operates specifically on the hydraulics, the electrics, the flight controls, the navigation systems, the engines, how that all integrates into what they're going to do for their mission, following the standard operating procedures and the checklist. That leads to flight instruction in full motion simulators that actually provide the pilot with not only a line operation experience, but also throws emergencies at them. And so they can see all the information coming in and manage that cockpit to the right way, with both of them working as a team. One individual is primarily flying the airplane and talking to the air traffic controllers. The other individual is talking to their company representatives on the ground, the flight attendants in the back of the airplane, and getting all the checklists completed so that the airplane can actually land on the ground safely. And we follow that up by the strong safety management team, systems in place that I'm talking about, which allows the pilots to fully disclose without any retribution what actually occurred. And we collect that data, and that data is looked at other data that comes in from the aircraft as well. And we look at what really is going on, and we figure out how to maybe mitigate that risk in moving forward in the future. Without that data, like it's been discussed here today, we will never really understand what the full errors are, maybe until after an accident. That's what goes on in North America. That's what's produced the safety record that we have today and gives the passengers comfort to get on our aircraft. And where was that just recently shown in full place was with the United 777 that just had a massive engine failure. Those people got back down on the ground safely, but up in the cockpit, you had 2 pilots working collaboratively to manage that emergency, figure out where the mountains were, stay clear of the mountains, and let's get this airplane back on the ground using their human performance experiences that's been talked about here, running their checklist, making sure that they have their weight is correct on their landing distance, and everything that went on to that that flight. And that flight is an example of the training and flight qualifications that we have here in North America. Now I want to focus on what's recently occurred, which is why I believe human performance is being looked at, in a really more microscopic manner. So about in fall of 2018, we had an accident of the 737 MAX. If you haven't seen that accident investigation report, it was well done. The Indonesian authorities put out a great report. And what I want to focus on is not the accident flight. I want to focus on what was in that report on the flight prior to the accident flight. During that flight, prior to the accident flight, the crew experienced the same problem that the accident flight had. The flaps came up and the airplane wanted to pitch over and go into the ground. And they fought it back and forth and eventually got the cutoff switches, the pitch cutoff switches turned off, and were able to control the airplane finally. But let's talk about what the accident report talks about next, that what occurred. Unlike that United 777, these pilots did not declare an emergency, okay? They didn't let anybody else know in the air traffic control system or their company that they had just experienced this problem. They basically flew from their departure to their destination with the stick shaker, which is the control stick in the column, rattling back and forth, making huge amounts of noise. Noise that you could probably hear if you were sitting in the front of the airplane as a passenger. So they didn't land short, they didn't declare an emergency, and then when they did finally land, they didn't have confidence that they could actually report in a voluntary way what really occurred on that flight deck and on that aircraft. Yes, they were able to successfully walk away from that, but they really didn't tell anybody else what happened. As a result, there was some maintenance work done. The aircraft flew, the next flight had the same exact problem and crashed. Now, if you think about that, it's mind-boggling. If you're a North American pilot on this call today, or if you're a European pilot on this call today, you are thinking, how in the heck does that ever happen? What kind of training did those pilots have? What kind of relationship does the company have with the labor employees that are operating that aircraft? And that's the thing that we're trying to address currently at the Airline Pilots Association, up at the International Civil Aviation Organization. Up at the international ICAO, the International Civil Aviation Organization, ICAO, based up in Montreal, develops the standards and practices for the world in the global aviation market. One of the things on their books is something called a multi-crew pilot license, which is a way to get into a cockpit. That license allows an individual to go through 240 hours of training, 40 of which are only required in an aircraft, flying an aircraft. The other 200 hours can be done through some kind of competency-based training, and you get your multi-crew pilot's license. If there's an operator out there that will hire you, you can take that multi-crew pilot's license and go in the right seat of a 737. And that's happening in the world today. Is that the way we should be doing business with the automation that we're describing? The automation that we're moving forward in these airplanes, they require more training, not less. It's clear, okay? More training, not less. And they need to understand how to fly the airplane. Our regulator in the United States understands that. They are behind us by saying, we need to have more manual flying done, not less. More manual flying in the simulator and in the actual aircraft. Turn off the automation when you don't have to use it. Fly the airplane from 3,000 feet to a base turn and land it. Get to know how the rudder and the stick and rudder skills actually operate, so that when you are in an emergency situation and you have to turn off the automation, it's not the first time you've had to do this. So back to ICAO, 240 hours. I use this example a lot and I'm passionate about it. How many hours do you think you need to comply with in training to get a hairstylist license? And if you think about that, depending on where you live and what state you're in, it's roughly about 1,000 hours. 1,000 hours to cut somebody's hair, yet you can get a license for 240, 40 of which are only in an aircraft, and go out and fly in the 737 MAX in the right seat, putting an enormous burden on that captain, which is clear in the data that we've seen from the accidents. The captain, you're putting him in a situation where it's almost unmanageable. It really is. So it's something that we're addressing hard. And we've advocated for ICAO to stand up a pilot training and licensing panel, and they have. And we are part of that through our relationship with the International Federation of Airline Pilots Associations. We're taking part in these discussions that are looking at what are the appropriate standards and recommended practices throughout this world. How should we operate this system so that anybody can get on that aircraft and feel safe that they're going to get to their destination? They're looking at automation on this panel. They're looking at competency-based training. They're looking at flight simulation. Should we be conducting business in a full flight sim, or should we be in a fixed base sim? When is it appropriate to transition one from the other? And then finally, they're looking at the effect of women and minorities in the training pipelines and how they get into the cockpits as well. I'm super excited about this panel. We're investing a lot of resources into this because clearly we have to do better. Those two accidents, we can't let that happen again. We cannot let that happen again. The enormous amounts of financial impact that those accidents caused make it important for us to do better. And I will tell you this too. When I was a test pilot in the Navy, after graduating from the Naval Test Pilot School in the United States, I went and worked with a lot of great engineers, and we had a lot of great projects. At that point in time, the F-18 Hornet built by McDonnell Douglas was coming onto the Navy as the new fighter, and the software was getting upgraded every 2 years, along with new weapon systems. And working side by side, those great engineers at the time, dealing with all the different specialties, we tried to get it right, but we knew at the end of the day, nothing was going to be perfect, which is why it's important when we do get done and we do get our products out working in the system, we have to ensure the operators that are operating those products feel comfortable at telling us what's really going on so that we can mitigate that risk, either through an update in the software or maybe through our training. But we need to collect that data, and we need those pilots and those crews to be comfortable around the world to be able to write reports without being retaliated against, without losing their license, without losing pay. Okay, that's what's really going on, and that's where we are going to collectively get better and maybe not have two incidents like this that we had in the future. With that, Terry, I know it's getting late. I'll turn it back over to you. And once again, thank you. And I will say this, it was a hard year financially for the Airline Pilots Association due to COVID. But I've got to figure out how NACA gets on that board, and we're not on that board as one of your sponsorships. And let me work on that as well. So thanks today, Terry, for letting me address the group.
Well, thank you, Bob. Really appreciate your insights. You hit up some great points, and I know they were well taken by everyone listening. So again, thanks, Captain Fox. This concludes our webinar for today. My sincere appreciation to Dr. Kathy Abbott from the FAA, Christopher DeSalvo from Collins Aerospace, Professor Colin Drury from Applied Ergonomics, Dr. Barbara Holder and Dr. Ratan Khatwa from Honeywell, and Dr. Florence Reuzeau from Airbus. Thank you all for your valuable contribution this afternoon. And again, thank you to our sponsors for today's webinar, Collins Aerospace, National Air Traffic Controllers Association, and the Aircraft Owners and Pilots Association, and Garmin. And for the audience, thank you for joining us today. I hope you found today's presentations educational, inspiring, evolving. And again, these webinars are being recorded, so if you want to review anything presented today or any of our past webinars, you can do so by going to the RTCA YouTube channel. Now, next month, we're going to take a short pause on this series because we're going to be teaming up with our colleagues at EuroCA for an International Aviation Software Summit on June 23rd and 24th. And this summit's going to include 6 hours of live programming and 12 hours of on-demand sessions. And you're going to hear from leaders at the FAA and EASA, including Ali Barama from the FAA and Patrick Key from EASA, along with industry panels from Joby Aviation, Airbus, Honeywell, Green Hill Software, SAE, and others. So our next webinar in this series is going to be held on Wednesday, July 21st, again at 1:00 p.m. Eastern Time. So again, thank you for being with us and have a great day.